Hey guys, let's jump right into solving quadratic equations by completing the square. So we've already kind of talked about this a little bit when we did the review in class and in some of our previous lessons, but let's just kind of look at how we would do this. So we want to factor this side of the quadratic. Well, remember to factor it, I look for factors of the positive 4 that would add together to give me negative 4. So in order for it to be a negative sum, but a positive product, I know it's going to have to be a negative times a negative. So I'm thinking negative 4, negative 1 is not going to work. So it must be negative 2 times negative 2. If I add those together, it does give me negative 4. So I'm going to rewrite this as x minus 2. And I could write times x minus 2 again, but rather than write it twice, I'm just going to write x minus 2, this quantity squared, is equal to 25. So we have rewritten this as a perfect square. This is a squared, some number squared, and we see that this over here is a perfect square. So what that then allows me to do is take the square root of each side. If I take the square root of anything squared, I'm just left with whatever was squared. So now I have x minus 2. And when I take the square root of this side, I'm left with a plus or a minus 5, because if I have positive 5 squared, it's 25. If I have negative 5 squared, it's 25. Okay, so now what we can do is solve for x. So we're going to add that 2 to both sides. So we have x and a positive 5 plus 2, which equals 7. Or we have x where we have negative 5 plus 2, which is negative 3. So my solutions are negative 3 and 7. This is my solution set. So x could equal negative 3, x could equal 7. And we can write this using our set builder notation from earlier in the year, x, such that x is equal to negative 3 or 7. And there it is. All right, moving on. Let's try to solve this one now by completing the square. I would love for you to pause the video. This is done identical to how we just did this one, and try it on your own. Okay, unpause, and I hope that you discovered that x is equal to negative 5 and x could equal 43. All right, moving on. So this says using the square root property. We're going to use the square root property to complete this or solve this quadratic. All right, so what should we do first? Again, I'm going to think about this. Okay, what are factors of 144 that could give me 24? And I know that that is 12, right? 12 times 12 is 144, and 12 plus 12 is 24. So I'm going to have x plus 12 times x plus 12 is equal to 192. So at this point, what am I going to do? Well, we can see that this is a square, and this isn't exactly a perfect square, but we can still use the square root property to take the square root of both sides. So I'm going to go ahead and do that. So I have x plus 12 equals plus or minus the square root of 192. Okay, so now let's think about this. 192 is not a perfect square, but we can probably break it down into something that is a perfect square. So I'm thinking about 192 and some things that it is divisible by. So let's see here. I can see that it would be divisible by 2. So 192 divided by 2 would be 2 and 96. 192 could divide by 3, and I get 64. And I'm going to stop right there because I see that 64 is a perfect square. So I'm going to rewrite this square root as, I'm going to keep my x plus 12 over here, equals plus or minus the square root of 64 times the square root of 3, right? 64 times 3 is 192. I just broke it apart. You might ask, well, why in the world would you do that? Well, the square root of 64 is 8. So I know that I can have x plus 12 plus equals plus or minus 8 square root of 3. Now I have a simplified square root. So now if we want to take it a step further and go ahead and solve, what we can do is subtract 12 from both sides. So I have x equals plus or minus 8 square root of 3. subtract 12, or what would make more sense is put the 12 in front, so it would be negative 12 plus or minus 8 square root of 3. So this is what x is equal to. X is negative 12 plus 8 square root of 3, or x is negative 12 minus 8 square root of 3. Now, if the problem asks you to simplify it further, you could go ahead and find it out, but this gives me an exact answer. There's no estimating here. The square root of 3 is irrational, so if we break it down any further, then it's going to give me an irrational number. But if we go ahead and try that, negative 12 plus 8 square root of 3, I get 1.86 if I round to the nearest hundredth, and negative 12 minus 8 square root of 3 gives me negative 25.86. So these are my two solutions. So the difference between this problem, these two problems up here, and this one is that these I could take the square root of it and get a perfect number. This one, I cannot. I cannot take the square root of 192 and get a whole number. I get an irrational number. So I could either leave my answer like this if it asks for an exact answer, or if it says estimate by rounding to the nearest hundredths, we could do this. Or if it said estimate by rounding to the nearest tenths, we would have 1.9 and negative 25.9. So it just depends on the directions of the problem. All right, so I would like for you to pause the video, and I want you to try this problem. And before you pause, hopefully you haven't paused yet, I can give you this little hint. Divide everything by 2 first, so that your leading coefficient is 1. So go ahead and do that first, and then try this problem. All right, so I took the liberty to go ahead for the sake of time and work it out. So I looked at this, and I know this is a perfect square. So square root of 529 is 23, and 23 plus 23 happens to be 46. So that's how I quickly figured that this was x minus 23 squared. This is a perfect square trinomial. And then I look at this 36, and it's a perfect square, but the problem is it's a negative. So don't let this scare you. Don't let this get you hung up. Go ahead and work it out just like you would before. Take the square root of both sides. So we have plus or minus the square root of negative 36. All that negative means is that we can rewrite it as the square root of negative 1 times the square root of 36. And we do that because the square root of negative 1 is I. Then we look at this. The square root of 36 we know is 6. That's easy. So we get plus or minus 6i. So my answers are 23 plus 6i and 23 minus 6i. So what that says to me is this quadratic, I know it's a happy face quadratic. I'm not exactly sure where it is, but I know that it's somewhere either up here, maybe in the middle, I don't know, but it's up above. It does not cross the x-axis because it has imaginary roots. So that's what that means to me when I look at it. So now what we're going to delve into is looking at the quadratic equation by completing the square. And the way that we do this is we take an equation that's written in the form of x squared plus bx. Notice there's not a c, or if there is a c, maybe we move it to the other side of the equal sign. And we find half of b and we square it. Then we add it to the original equation. So let's look at this. We've got this equation right here. This is not a perfect square trinomial, right? If I have the square root of 4 is 2, but 2 plus 2 is not 18. So what I'm going to do is I'm just going to move this 4 over to the other side to kind of ignore it. So I end up with x squared plus 18x equals 4, right? I'm allowed to do that. Add 4 to both sides. So now I'm just going to focus in on this half, and what I'm going to do, it says find half of b. Well, what's half of 9? Or half of 18? I just told you it's 9. I take half of 9 and then I square it. Well, what's 9 squared? 9 squared is 81. So I'm going to add 81. But this is an equal sign here. So for the sake of equality, if I add 81 on this side, we know we must come over here and add 81 on this side as well. So now I have a perfect square trinomial over here. So we can rewrite this as x plus 9 squared equals, well, 81 plus 4 is what? 85. So I have 85. So now we want to solve it. Ooh, this is going to be fun. Well, we can use the square root property now to take the square root of both sides. This isn't exactly the prettiest thing to take the square root of, but we can do it. So I take the square root of 85 and I have x plus 9 equals plus or minus the square root of 85. Looky there, I'm already over my 10-minute. Sorry, I tried to be short and quick. So now what I'm going to do is I'm going to subtract 9 from both sides. So I have x equals negative 9. I'm just moving this positive 9 over to the other side to subtract it from both sides, plus or minus the square root of 85. Now I'm thinking there's a way that maybe I could simplify 85, but it didn't tell me to give an exact answer, so we're just going to go ahead and estimate negative 9 plus the square root of 85, and that is 0.22. Or if we do negative 9 minus the square root of 85, I get negative 18.22. All right, so I'm going to give you this one to try, and I'm going to go ahead and give you a little hint again on this one. The problem with this one is, again, the leading coefficient is not 1. So first we've got to get rid of that 4. How do I get rid of the 4? Well, I divide all of the terms by 4. So start there and then use these rules to complete the square. Unpause the video and I will have your answer for you. All right, so let me run you through this really quick before I end this video. I moved the 27/4 over. I took half of the middle term, which was negative 3. Half of negative 3 squared it gives me 9/4. So I add 9/4 to both sides to keep that property of equality true. Then I rewrote it using the complete the square method. So x minus the 3/2 squared. Since this is a perfect square trinomial, I can do that. And I added these together and got 36/4. Now, I went ahead and kept it that way because I kept it as a fourth because I knew when I saw this that I was going to be adding it, and that way it made it easier to add. But I mean, you can punch it on the calculator, it doesn't really matter. Either way you go, you get 9. So when I take the square root of 9, I get 3. I add the 3/2 to both sides. So 3/2 plus 3 is, what would that be? 3/2 plus 3 is like 9/2. I believe. And so I reduced that to 4.5, and 3/2 take away 3 is negative 1.5. So my solutions are negative 1.5 and 4.5. I hope this made sense. If not, hopefully you join me in class for some of the practice problems that we do together. And that's all I have. Have a great day, guys.